Perfect. Thank you very much for the intro. So thank you very much, guys, for spending this time with us. And yeah, today I just wanted to introduce you Einblick and just the general idea behind the platform. My name is Benedetto Buratti, and I'm one of the co-founder and head of data science at Einblick. So the project itself started really as an academic project back at Brown University and MIT. And so as a research project, the Einblick, or like North Star as it was called back then, actually has a really long history. Is more than 6-7 years of research. The company itself actually was spin off in 2020, right before COVID. So with perfect timing there. And we have really good, really good initial like funding from DARPA that kind of directed the idea for the research. So the goal was essentially to automate the building of machine learning model, so AutoML, so to speak, and essentially everything that the intersection between human-computer interaction, database systems, and machine learning. So right now the company it's growing, it's going pretty well, and we're having like good traction, both on our SaaS deployment and on deployment with like large companies. So we're trying to embrace the data science community at large. So the whole idea of the research project really, and then of Einblick as a company, just started from the realization that data science today, it's a really lengthy process. Right, that requires a lot of technical skills, technical background, and essentially the amount of data scientists that available in the workforce is simply not enough to satisfy the demand. So a lot of tools have been developed to go away from this, code-based only development process, and so some like workflow engine type of platform were designed, but really the story behind the complexity between machine learning is not that different, right? Still, those tools require a deep expertise in data analysis and data science, and they're really not designed to allow domain experts or subject matter experts to participate to the analysis. So usually the workflow that occurs is that there's a wide variety of tools, right, that satisfy different functions of the data analysis pipeline. So there's some tools that focus on data gathering, other on data preparation, exploration, model building, and so on and so forth. All of those are kind of technical, more technical tools, maybe at the end part of the life cycle when we need to showcase the results, maybe even folks with less technical background. And here by technical, we mean purely coding background. Can use some of those tools, but still like that entry barrier is quite substantial. So in general, the analytic lifecycle, it's pretty slow exactly because of this reason. On one side, it's really hard to align people from different teams and different backgrounds because essentially there is a wide variety of tools, wide variety of functions, and interdisciplinary teams are required to solve data science task, like by definition, right? If you think about a use case, usually you have a person that is on the business side that really understands the business dynamics and has priorities, goals, and objective in that domain. And the other side, we have technical folks that have completely different objectives, at least from a background perspective. And so what happens is that a lot of time, those two type of people really are speaking two different languages. And so the alignment is really time consuming. On the other side, as we saw in the previous slide, all the whole analytical pipeline requires a lot of different tools. And some tools might be prerogative of technical people, other of non-technical people. And this in general, if the goal is to have an end-to-end solution to a specific problem, just creates frictions and it doesn't really deliver efficiency there. And the third one, which is a more technical aspect, I would say, is that, and I will dig into more about this topic, is that big data on large, big data and data analysis or machine learning, they're really don't work well together in terms of collaboration, right? So if we need to collaborate on a really large data set and we need to deal with a really big data set, well, we are kind of out of luck if you think about it, because even to run a really simple operation, it's quite time consuming. So I hope that by the end of the presentation, you will see how Einblick essentially tackles all those three different points. So on a high level perspective, Einblick is a web-based application. It's a data science platform that kind of combines the best of workflow engines, notebooks, and dashboarding tools. So as you can see from this video, every operator is like a mini dashboard, but you have also this workflow type of analysis that allows you to build really complex workflows and produce different type of visualization, manipulation of your data, and also build data apps or machine learning models. What you're seeing here is Einblick in action and on a big touch device. This is a Microsoft Surface Hub, but you can really use it on any device that supports a modern web browser, like a Chromium-based browser. So, and I will show you what I mean in practice. So I wanted to give a quick introduction on the technical challenges that we tackled to build the tool first, and then just show the platform in action. So the first part that was core of the research project was really redesigning the way of interacting with data. So I guess all the people that are listening in, they're familiar with, Minority Report type of dashboard tools where you have people play, like, you have detectives playing with data, moving things around. So that type of thing really stuck in the collective imaginary, right? Like everybody, when they think something about analyzing data, their thought goes always in that direction. So that was one of the main lead in the research in terms of human-computer interaction, how we can make data analysis as intuitive as, this type of movie. So that's why there's touch support and works on touch screens, because we want really to enable real-time collaboration both in person and in remote, as I will show you. The second part is really in the progressive part of the backend. So if you think about collaboration, once again, if you want to run a filter, let's say on a really large data set, maybe not even massive, maybe like in the order of tens of gigabytes or hundreds of gigabytes, even a really simple operation might take several minutes, right? For not talking about more complex ones. So given that our goal is always to provide interactivity in collaboration settings, we build a progressive engine that essentially behaves as a streaming engine, in which even if you have a really large data set, we're going to take a sample of your data, build a quick approximation of any job that you send to the backend, so that, let's say you want to plot an histogram of an age distribution. You get a first approximation of that distribution. You can keep going, and then in the meantime, while you keep going with your analysis and you have an approximated result, the system will automatically scale on the whole data set, right? Third one is to align all the different pipeline and operators to this design goal. So we have data mining techniques, one is called a key drive analysis, that essentially it's useful to find differences between two populations, or our RML. All of those operators that you have in the platform, they really work according to this progressive paradigm. So anytime that you run an RML job, you can immediately drag out a pipeline. It's not going to be the best one that you're going to have, but you can keep going with your analysis and then come back if something better was found, and then just swap it with the one that you're using. So in general, why Einblick is different, right? In summary, it's just because it enables technical, non-technical people to collaborate together. On the other side, collaboration brings better results, right? Because it's often easy to say, to spot a person that is not able to code, right? And say, oh, that will be beneficial if that person is able to code. So it's clear how code is empowering. But on the other side, also becoming a domain expert is quite empowering. Like just think about data scientists analyzing a data set without any minimal business context, right? Probably the analysis output can be as rigorous as you want, but maybe is not going to deliver a solution. Probably it's going to lead to an over-engineered solution. And so in summary, allows people, this tool, this type of innovation really allows people to have rapid prototyping and shorter time to insight. So yeah, this is a little bit a summary of what Einblick is trying to do. Is try to build all those different functions in one canvas, such that people can collaborate and have like a shared grammar across different domains. I just wanted to give a quick intro about the progressive engine and how it works. So it's pretty straightforward on a conceptual level. So you can think that you have your system, and you're trying to build a distribution of salaries, let's say. So you have your data in your data warehouse, and let's say that your memory is, let's assume it's empty. So what you're going to do essentially is to pull some data in, and then you're going to have some, approximation of the distribution. And then this distribution is going to be refined the more and more data is provided to the system. Same thing for, same thing happens for the AutoML. So the first model that you're going to get, again, is not going to be the best one, but the more time you give to the AutoML, the more it can scale on the whole data set and improve the results. Those are some tests that we did in the past against experts, data scientists building baselines. So these are anonymized. This was part of our research project funded by DARPA. So the system Einblick was able to solve all the problems, and if I remember correctly, it was more than 100, more than 200 problems, different data science problem, and our AutoML actually outperformed data scientist baseline by performing model selection, hyperparameter tuning, and pre-processing. In general, what are the concrete implication, like visible, tangible implication of having a computation engine? So I'm going to show this real quick in this video that we created. On one side, we turn off the progressive engine. So on the right, you have the progressive engine, turn it off. And on the left, it's on, right? So this is our platform. So it's exactly the same machine, same resources. So what I did now is to connect this top plot in both sides by selecting flights. This is a flight data set of 30 gigabytes. And I'm just selecting flights between the 2014 and 2015, right? It's a simple filter, or like where clause in SQL. These are what you can write queries in Einblick, by the way. But what you're going to see is that after not even a second, as you would expect, if you think about this, you immediately get an approximation of your distribution. On the other side, the data is still loading in memory, right? So if you need to wait just for the data to come into memory, you're going to wait an immense amount of time. So what we provide for every operator is the operator progress, just to show like the transparency. So you can see here, I don't know if it's too small, but right now the system read like 8% of the data, right? And so I just speed up the video in this case because essentially there's not much information in the middle. But what you're going to see at the end, and maybe it's like the provocative thought of a progressive engine, is, would you be willing of waiting more than 6 minutes to get a result that is approximately the same that you can get in less than a second? So this is really the question that is asking you. Even if you know that eventually you're going to get the same response, because you can see that in 6 minutes, both systems return the final result. So progressive computation is really a way to guarantee real-time collaboration on our platform.
Wow, that's phenomenal, Benedetto. Yeah, it's just sitting here kind of twiddling your thumbs. The faster you can iterate, I guess, right? The faster, the more productive you are. Somebody asked a question here, like, have you compared your, and maybe you'll mention it later, but your AutoML against maybe offerings by AWS and Google?
So we did some testing back then with other commercial offering, but this was still back when we were doing a research project.
I see.
So we compare with Azure AutoML. Yeah, but not with the current version of our AutoML essentially.
Okay, understood.
Yeah, and in general, like I just wanted to show some also experiences from a user study that we conducted. I'm going to be quite fast on this. Just want to show you like a breakdown on the different type of function that you can perform using data analytic platforms. And this is a paper that we wrote to really advocate for the drag and drop analytics type of platform and really try to push also data scientists to embrace those type of tools for rapid prototyping. So you see here, you have a breakdown of different high level data science tasks like data visualization, data manipulation, so on and so forth. And then you can see how two tools like NIME or Einblick, they're essentially constantly better than notebooks. So this plot is just showing like the red circles are where there are missed tasks for a user study that we run. So essentially there were a lot of different tasks for each one of the testers that use different platforms. And the message for this paper that it's under review now is really that no code or low code platform like Einblick or even NIME, there are a valid tool to add to the data scientist toolkit, right? So I just wanted to have this note here for the more technical folks. So in general, like I just wanted to jump into the demo itself. I just want to remind the folks on the line, if what you're seeing in the demo it's interesting for you, you can go on our website, Einblick.ai. You can actually create an account for free, right? So we are really always willing to engage with the data science community. We're always willing to get feedback. So you can go to our website, explore the platform, get feedback, and just tell us what you think about the tool. So now I'm just jumping in our demo environment. As you can see, I'm just using Google Chrome, and I will just give a quick end-to-end use case of the platform. So what I'm going to use is a data set that comes from a large car manufacturer. So it's a lease data. So what this data set contains is transaction or like data from customers that actually got a lease from this car manufacturer. And the goal is to check why some people are accepting a promotion to renew their lease or not, right? So here on the left, you can see I have a data frame. I can immediately start exploring this by drag and dropping onto the canvas, resizing my window, and then I can start checking out the different attributes. So you can see, for example, you have different age attributes, some information about the lease on the car, the price of the car, and then if they accept it or not. There are also other information, but I will talk about that later on. In terms of functionalities, we try to automate as much as possible. So if you want to profile your data to check like distribution, min max values, so on and so forth, you can use the profiler operator. And again, this is really the human computer interaction part in action. So you can see the distributions and min max values and so on and so forth. We try to automate this as much as possible. But if you have a more targeted goal, as we have for this use case, let's say understanding why some people accepted a promotion or not, you can select a single attribute, select the column name and drag it onto the canvas and immediately visualize the breakdown between people that accepted or not, right? As simple as that. And we try to guess as much as possible the visualization based on the data type. So if you select an age attribute, I'm going to show you the age distribution for this visualization. But you can also use categorical attributes, right? So I can check out the education level for this data set. And again, this is like a 2D unbounded canvas, right? That really gives me as much space or freedom that I want. Every operator has an input antenna, which is the input data frame, which as you can see right now is just one, but nothing is essentially stopping me to adding more and more data sources to this data set, right? So now I added a bunch of those. and I could potentially use all of them and join them in the canvas. I'm not going to do this, otherwise the use case becomes too complex, but you can do data manipulation in the platform. What is nice about the tool is that you can actually use visualizations to write queries, right? So let's say that I think that age is someone related to the acceptance rate, right? I have this hypothesis and I want to test it out. So the first thing that I want to do maybe is to check out what's the age distribution for the people that accepted. So I just selected just the people that accepted. I'm going to connect this to the chart. And then now you see an updated distribution that is just for the people that accepted. You can also have more complex visualizations. For example, I can brush this. So brushing is going to highlight this subpopulation that I selected here in this subpopulation. So now you have this orange portion of this plot that is highlighting the people that accepted. What you can also do is to normalize this plot. And what it's showing you is that for every age group, is telling you what's the percentage of people that accepted. And so for this use case in general, you can see that there is upward trend, and folks, after 50 years old, essentially it's more than half of the people that accept. Probably they have more money, maybe they want to get a new fancy car, but for young folks, essentially this is not the case. And what you can do is also combine different visualizations. So what I did now, I can also do the same for the education level. So let's say that I want to select bachelor degree. I can connect this to this other chart. And then I can do exactly the same thing. I can select the brushing selection, and then essentially you're going to have that brush one are the people that accepted, so majority, and then brush two are the people that have a bachelor degree, and then the overlap between those two categories is the pink area, right? So you can go really simple or really complex depending on the use case and at which point you are in the learning process of the tool. So regarding the use case itself, like trying to understand why some people accept it or not, what I wanted to point out is that you can definitely use this approach and have a really manual slice and dicing process. And this is often useful if you already have an hypothesis in mind. If you need some help in terms of finding interesting facts about the data, maybe because it's the first time they are exploring this data set, what you can do is to use the key drive analysis operator and use the same technique of filtering that we used before to find difference between two populations. So the test and control in this case. So what I'm going to do is to select the accepted attribute as I did before and create a duplicate. Right. So now I have two charts like this. Also, by the way, using visual queries as I'm doing that right now greatly increases the transparency and readability of a workspace, because you can clearly see that I'm telling I want just the people that accepted as my test population. I just want the people that did not accept as control. Right now, my input antennas are empty. So those are just filters. So what I'm going to do is just take the original data frame and add it to both. So it's the same data set, but filtered by two different entries. And so what this allows me to do is to essentially mine the whole data set and find differences between those two groups. So we'll start really simple to get some first insight. And then I will make this, I will use more advanced functionalities of this operator. So the first result that you get are 4 columns. The first one are the key drivers. So you can think of this as the differences between those two populations. And then we have test prevalence and control prevalence. They are just the percentage of rows that contain this pattern here on the left. And then the relative difference. So it's just the relative difference from those two numbers. So why this operator is really useful? But well, essentially it's just because automatically it tells you interesting insight about your data. So if you didn't know anything about this data set, you immediately can see that accepted equal true is 100% in the test population, 0% on the right one. Well, I mean, this is quite intuitive if we take a look to our filter, right? But then you start seeing that applied online and applied to dealership are just present in the left population. And actually those two numbers sum up to 100, right? And so this means that probably if they apply the line or at the dealership, they already accepted, right? Because there's 0% on the right. So we might be careful here for data leakage. And then, general information about age, this age group between 39 and 52, they represent 43% and 26% on the control. And in general, like if at any point the user gets confused, they can always click on any of those numbers and they get a clear, plain English explanation of what this means. So it's a really great tool to find differences between two populations. And you can really think about this operator as the connection between descriptive analytics, so the world of visualizations, correlations, and statistics, to the world of machine learning, right? So what is doing this is a more rudimentary version of machine learning that is explainable for and easily interpretable. If we want to move to machine learning, the go-to operator in this case would be the AutoML. So the AutoML operator is, again, was a big part of our research back then when we were in academia, and still is one of our core operators in the canvas, allows people to train predictive models quite easily. So you can just specify a train and then specify a target variable, features. So we saw before from the key drive analysis that probably we should remove those two attributes, but let's keep them just to check what happens. And then as we can pick a metric and the runtime, let's do 5 minutes. The reason why I put 5 minutes is really because I want to show you the progressive engine in action. So the other operation were kind of fast, so you can see what was going on. But the progressive engine, what it allows you to do is that even if we set up this operation to run for 5 minutes, at any point, you can drag out a pipeline and check out what's going on. So for traditional AutoML engine, you set an optimization process, you check the results, and then you need to go back, right? And maybe you wasted 5 minutes in the best case scenario, hours or days in the worst case scenario. Instead here, this is still running. I can immediately start checking what's going on. And if you check how much data is used, like we are not completed the whole operation yet. But if you check out the feature important that you get for free every time that you build a pipeline, you can actually see that apply the line, apply the dealership are the two dominant patterns. And if you really are skeptical and you don't believe what I said before, you can always go back to the good old descriptive analytics. You can literally take the accepted attribute, apply the dealership, and apply the line, and you can double check. So that's what, if you remember the plot that I showed you before, this one of the different kind of tools, right? So this is really what we're trying to do here, like going back and forth between machine learning, visualization, data manipulation, so on and so forth, right? So I have something that is fishy. I want to understand what's going on. I need to plot this because I want to show to my end user, the consumer of my analysis, what's going on. And so I'm going to prove visually that we shouldn't use those attributes, because if you check the brushing, right, just the people that accepted have either applied at the dealership or applied online, right? So going back and forth visualizations and predictive modeling. So I can just go back here, deselect those attributes, rerun the model. Probably this is not super useful, and I can just delete. And now, you can see that there's the curve on the x-axis. We have the runtime on the y-axis, the accuracy. Again, I can at any point take a pipeline. Doesn't matter if the process is still running, and I can start exploring what's going on. And I don't need to wait for the end result. I can keep going, use the executor, start making prediction using probabilities, and everything. The goal of the platform is really to explore data at the speed of your thoughts. So there are other functionalities, like now that you build the dashboard, you build like a pipeline or like analysis pipeline, you can add this to a dashboard, for example, and then you can share with people that are not interested in the analysis itself, but they're just interested in the output of your analysis, for example. So I'm adding those to a dashboard. I can rearrange things here, and then I can publish this dashboard. You can code extensions for the platform. So if you have a really custom function that you want to build, you can either use a Python script right into the canvas. You can add your data frame here, and use pandas, pandas syntax to do whatever you want. You can import packages as a pip install and so on and so forth. But I just wanted to be mindful of time and maybe stop here for the Q&A if there are any questions.
Wow, that's super powerful. That you can take a look at that stuff in real time and just essentially go back and, like you said, cross-validate, but then also just make a tweak and then watch it and not have to wait 5, 10, 15 minutes, an hour, whatever it is. That's super powerful. Matthew, you had a question, and I would rather actually just have you, if you could unmute.
Yeah.
Ask yourself.
Yeah. So when you were doing, I think the KDA, you were doing filters based on your original data set, and then you had to drag those data frames in. I'm curious what would happen if you had dragged in other data frames or the data sets, and if there needed to be a join key set in advance between those.
Yeah, good question. Good question. So in this case, like the two data frames, they need to share the same structure. So essentially, if you're bringing two data sets, they need to have matching column names. And what the operator will do is take the intersection between the column names that match, right? So in this case, exactly the same data frame is just filtered in a different way. So there's no issue. Let's say that you have two different data frames which overlap on 5 columns, then the system will just use that overlapping 5 columns.
We'd use all 5 of them as join keys. Okay.
Yeah. So essentially, we'll scan the left data frame on that 5 columns and look for patterns. Do the same thing on the right one, and then say, okay, based on the patterns that I found, those are the patterns that are most different between the two data frames.
I might have missed it during your thing, but how did you load the data? This is all sample data that was already there.
Yeah, exactly. So I'm going to go back to the user main menu. So there are a couple of ways, like those are all the canvases. By the way, you have kind of multiple canvases for different use cases. So you can really think of a canvas as a workbench. Every time that you create a canvas, you can connect multiple data sources. So in general, the easiest way is to just upload a CSV file. And if you click here, you can just use your file manager, local file manager, and file system. And if you want to have SQL data set, you can create a connectors. We have like quite a variety of connectors to commercial available tools. So you can, I don't know, if you have an Oracle database, you can just type your host, the port, and so on and so forth. And then you can write, once the connection is established, you can just write the SQL query. You can be like, let's select star type of thing and just pull the whole data.
Does it cache the data on Einblick side, or is it rerunning the query every time?
So that's an interesting question. So we don't store anything. So everything, all the computation remains in memory. Right. And so what happens is that if you're using a CSV, we're going to pull the data in memory and feed as much data as possible. And then we're going to stream essentially the results. If the data set is too big, we're going to create a reservoir sampling for you so that we can process the whole data set. If instead you're using a database, we're not going to have like side effects. So we're not going to touch your database. We're going to still like pull the data from your database, and we're going to use like push down predicates to essentially leverage the underlying database itself, right? So that we can kind of first start the job on our computation engine, then rely on the database. Let's say that you have a massive data set and you want to do a join, right? We're going to rely, we will start doing the join on our side. Once, however, the join is completed in the database side, then you will see that result. The idea is trying to decouple the immediate output that you will get from running like an operation like a join or even like a simple visualization, and then the end result. So we want the conversation to keep going, get approximate results, and then refine them as more computational resources or more time are given to the system.
I have to imagine then that if your database and your query are in such a way that the initial data that it pulls is not a random sample, your initial estimation may be way off from what your final result is.
Depends on the, yeah. So depends on the database system. Some database system, they do support random samples. So we can ask to the database to return us a random sample. Yeah, exactly.
So what, I guess you touched on it a little bit at the beginning, but I am kind of curious how you guys moved out of a research project to getting fully funded. I mean, what was that process like? Did you?
Yeah. So, yeah, I mean, it's I would say almost stereotypical startup story. I came to the US to do a PhD, and most of the other co-founders are either professors or they were like PhD students or postdocs. I think the turning point was really, we went to a conference in San Francisco. It's called Strata. I don't know if you guys are familiar. And we were there as a research project, pretty much. And I think that there was always like the idea that this could be cool as a startup. But I think Strata was a little bit the turning point because we got a lot of people from, Strata is an industry conference. It was not an academic one. And so there were a lot of people from industry that were really engaged with the tool and they were really curious about the tool. And I think that was a little bit a turning point for everybody. And we got, really the pulse of the, attractiveness of a tool like this for people in the industry. So, yeah.
Then did you have to go and raise money then?
Yeah, exactly. Yeah, but everything was pretty much smooth. I think everybody in the research group was kind of aligned on doing it because a lot of the challenges that we were addressing after the conference was kind of related to the, practical issues of doing data science. So it was kind of a trade-off of doing like research type of, a trade-off between doing research and actually solving like concrete use cases. And the two, there is an overlap between the two, of course, but then that overlap was becoming a little bit thin. So we spin off the company.
Yeah, it's awesome. So what's your pricing model? Because you guys have a bunch of free things, which I've signed up for and toyed around with.
Yes. So actually, let me go back to the pricing page. So in general, like if you want to test out the platform, we have a freemium tier. So consider that the tool for a long time was just we did just on-prem deployment. So we work with like government or large companies, and so we have those on-prem deployment, and so they belong to this world. This last tier on the right. In general, we open up the platform to the general data science community just to embrace as many people as possible, get feedback from the community. So the freemium tier allows you to do a lot of things. There is, of course, a limitation in terms of the canvases that you can have and the maximum upload size, right? So we just want to be sure that people are not abusing of the system. So there's a limit there. And the pro version essentially gets rid of those functionalities, gets rid of those restrictions, and it costs $100 per month and build yearly. So this tier is mostly thought for freelancers or people that are not professional data scientists and can use this on the daily job. But in general, like I would always suggest to log in the tool. Again, it's completely free, and there's onboarding workspaces. And one thing that I didn't show, but it's actually pretty cool. I don't know if it's going to show up given that I'm sharing my Chrome tab. I hope that it's gonna. Can you guys see two screens or just one?
Just the one.
Just one. Let me try to. I'm gonna stop sharing for a second and reshare again. Yeah. So one cool thing is that you can literally I'm collaborating with myself.
Sure.
But you can share like a URL with other people. You can also invite them using their email, let's say. And then once they're in the workspace, you can collaborate with them in real time. So that's all the real-time collaboration. So right now I'm on the left tab, and you can see that it's updated on the right tab. I can also decide to observe another user. So now the right user is observing the left user. So if I move things around, if I zoom in or zoom out, everything so will be connected. And this is extremely useful if you have folks that want to learn how to do data science, if you want to have boot camps or like workshops, you want to analyze data, this is perfect because everybody can join, just follow one person and that person will guide everybody. And then you can have like almost like breakout rooms in the canvas where everybody can collaborate on different pieces of the canvas. You can add bookmarks, for example, that allows you to jump in different part of the workspace. And really, you can almost use this and as a presentation mode, let's say. You can go live, as we say. So let me see if I give permission here. I'm gonna try to, yes. So you can see I turn on the camera on the right user. I can do the same thing on the left hand side, and there's the zoom. I need to get rid of the zoom. Yes. So you can see now I'm logged in 2 different workspaces, and then I'm collaborating again with myself. So it looks a little bit silly, but you get the idea, right? You can literally have like conversation with people.
Wow, that's huge. Yeah, like you say, have a real-time conversation as you're sort of dragging charts around collaboratively.
Yeah, exactly. That's the idea.
What's the Canvas technology you guys are using at all? I mean, are you using any open source stuff under the covers? You have to build all this from scratch. I mean, this seems really a lot.
So I was in the backend team mostly, and then now I work as a data scientist. In general, like the front end part is custom. Yeah. There's some, like technologies that open source packages that have been used, but the architecture itself, it's, a custom build essentially to allow it to do this. And same thing happened in the backend pretty much.
When you're working with users, what sort of analysis workflows are people having the hardest time doing in the platform that are like next on the roadmap for you to tackle and make easier?
So I think that right now the tool is pretty proficient in like doing quick prototyping. Like the most common use case is really have people from different backgrounds join the canvas. You have your business person, domain expert, IT person, data scientist, they collaborate, they have a first solution, they publish a dashboard, and then they iterate this process. So let's bring new data, let's add another visualization to the dashboard. This visualization is not clear, let's change it with another one. So this is a little bit the loop. Where we're improving the platform is to smoothing out this process. And this means essentially nice looking dashboard on one side, easier data manipulation, easier data ingestion. So we're essentially iterating on this whole workflow, right? Trying to make this use case as easy as possible, because at the end of the day, a lot of use cases really revolve around, let's first align on which data do we have and what it's the output. Once those questions are answered, it's just a matter of iterating. And so I think the platform right now does a really, really good job in aligning people. We just want to make it even easier to iterate on this process.
Looks like you guys have a number of, I mean, you guys work with DARPA and NSF and some other commercial companies too. I mean, has anybody, I guess, been concerned about the data privacy or any of those issues using your platform?
Yeah, of course. That's the reason why originally we did on-prem deployment. Large companies are, of course, they want to keep their data, makes sense. So that's why the enterprise tier is there for them. In general, like the SaaS tier was developed later on to allow like the broader community to be able to do this type of analysis. But of course, like it's a big topic, especially with the government, as you can imagine.
Yeah. Well, you mentioned you guys are growing. Looks like you guys have a careers page. I guess a number of different thing. Are you guys? Do you have to be in Cambridge or remote, or what are you guys looking for?
No, actually, we are a remote company. We do have an office in Cambridge. So I personally live in Providence, Rhode Island, so which is 1 hour from Boston. I regularly commute to the office just because I like to go to the office, but you don't have to. So we have people in California, other people in New York, a lot of people in Boston, but it's a remote company.
Very cool. Well, any other questions here from the team? Yeah, okay. Yeah, we had some people drop off here just recently because probably it's getting a little later for them. But boy, this has been awesome. Awesome, Benedetto. I really appreciate it. I think your guys' tool has definitely, I guess, hits the sweet spot in a certain area for companies that are looking to have more collaboration, I guess, as they're working on data specifically.